Let's talk about what contours are on a topographic map. Contours are the way that we show data related to elevation values graphically on a topographic map. And the way that we do this is by drawing lines onto the map. And these lines are drawn so that each line follows the same elevation, in this case, all the way around an island that this zero line would mean we're right at sea level. So if we look at this, the top part here is a topographic map with contours. The bottom part here is a three-dimensional block diagram, and it's showing an island in green here. And sea level, the current sea level is shown as the as this top of this blue A layer here, and we can see where the blue changes to green, where the water touches the land. This would be the same as our zero elevation contour here. So we could essentially trace this contour if we had a GPS by walking around this island, having 1 foot in the water, 1 foot on the land, and by the time we get all the way around the island to the other side, we would have a trace on our map that shows where the zero elevation contour is. Now we can imagine if sea level were to rise by 50 feet, we could do the same thing once again along this area where it turns like here from darker green to lighter green, where this B plane intersects the island, this horizontal B plane represented by maybe the ocean with 50 more feet of water in it, hits this island. We could draw on a second contour. Because we would be 50 feet above the original and true elevation of this island, we would call this one the 50-foot contour. And once again, if the imaginary sea level came up this far, we could walk around 1 foot in the water, 1 foot on land, and trace out this 50-foot contour that's shown on the map here. And these contours are typically represented in brown. We tend to label these contours, and we interrupt our contour line. We stop our contour line, we write on the number of what the value of the contour is, and then we start it up again on the other side. To complete the map, we can raise sea level a third time. So now sea level is 100 feet higher than it was originally. Now it's intersecting, going from this medium green to this lighter green here. We would once again trace that line around the map of where this horizontal plane intersects the topography, and we would get the 100-foot contour here. This map does not mean the highest part of this island is 100 feet high, because we can clearly see there's areas of this island that are higher. It just means that the highest part of this island is within this 100-foot contour, and none of the island gets up to be 150 feet high. If it were 150 feet high, if we raise sea level again, we could trace another contour. But in this case, if the ocean was 150 feet high, this entire island here would be underwater. So these contours are a way to represent elevation on a map, the actual data associated with this elevation on a map, trace it out as a contour line, and then we can either know exactly what the elevation is at any particular point, like we know right here, it's at 50 feet above sea level, or we can estimate what it would be between 2 points. For example, if we had a point right here, halfway between the 50 and 100-foot contour, the best estimate we could make of that would be an interpolation, where we're estimating what it would be between the two, and we could say the elevation is about 75 feet. This just shows kind of a 3D model with the contours on it. And once again, we can see this in this case, we're not starting at zero because this is not sea level here. We're somewhere up in the plains at about 2,000 feet above sea level, and this mountain here is going up to about 3,750. Here we can see that each time we go up a contour, we're going up by 250 instead of on the previous example we went up by 50. So a bigger feature, we use a different change between the contours. But same thing, right? We're just getting a series of lines that's showing kind of the shape of what we're looking at in 3 dimensions. So let's say we just started with some data. How would we actually make a contour map? Well, we would use a process called linear interpolation. As I mentioned before, we would just estimate the values between known values. So the known values would be represented by the points here. If I do a quick scan around this map, I can see the highest point on this map is 120, and the lowest point on this map, we have, looks like we have a 75 right in here. But let's say we wanted to put 100-foot contour on? Well, we do have one point that is 100 feet above sea level in this case. That's the one shown in yellow here. But that's the only 100-foot point we have on this map. So how can we put the other ones on? Well, one thing we can do is this process called interpolation. So if I put a line between a point that's 95 feet high and 110 feet high, and once again, I'm assuming that the elevation changes smoothly between those two, right? It could change very abruptly right before the 110 point, but let's just assume it changes smoothly. Then I can put two little ticks on the line to represent every time it changes by 5 feet. So we go from 95 to 100 here to 105, and then we're at 110 here. So now we know where our 100-foot contour should come through between those 2 points. So we're using interpolation to estimate elevation where we're not having an elevation of that value reported. We can estimate between any 2 points. For example, we would not expect to see a 100-foot contour between the 105 and the 120 here, because there's no reason it would be here, right? We would go 105, 110, 115, and then 120. But on this side, we would expect to have a 100-foot contour much closer to the 105 than we would to the 80 or the 75 or the 80 or the 75 here. So it's going to be close to that in all directions. So once we do those interpolations, then we can draw our contour on the map, and then we would have a 100-foot contour.